This video is about the middle circuit breaker here that failed catastrophically and took out the two other circuit breakers on either side, plus a couple of main circuit breakers, going all the way back to the main incoming supply to a factory and plunged a lot of the factory into darkness in the process. Quite a disturbing incident. But we'll talk about initially the fault that led up to this breaker exploding, why it probably exploded, and then we'll go back to the bench and we'll take it apart and see what it looks like inside, and indeed the other ones either side of it. So here's the story. The outdoor lighting circuit of this factory had been giving an intermittent problem. Every so often it would just go pop and it would trip the breaker, and you'd go and you'd reset the breaker and it would work for ages. This is a common problem. It's often caused by tracking. Tracking is where you've got two electrical connections in the vicinity of each other. Water gets into a junction box. It happens a lot. And if it was live to earth, it's not so bad, because if you get a carbon film forming with the tracking from live to earth, it's easy to find with an insulation tester. But if it happens live to neutral, it's very hard to find, because when the problem actually manifests as an actual short circuit, it often blows itself clear. And then there'll be that long delay where it just gradually, it has a high resistance and it just gradually crackles as sparks until it's built up a good conductive layer of carbon. Then it does it again, bang, pop, trips the breaker. And in that instance, say for instance a damaged underground cable, the fault is not there most of the time. You can't even use what's called time domain reflectometry testers, which send a pulse down the power cable and actually look for the reflection, because if the fault's not there, you kind of have to wait for it to become permanent. This is the curse of the electrical industry. But anyway, in this case, the fault was blowing itself clear, the circuit breaker was reset, and sometimes when this happens, as the fault gets worse, it pops a couple of times. As soon as you turn it on, it pops, and this used to happen a lot. Well, it still happens with inrush current to load. Sometimes you've got a high number of peak inrush current loads that when you turn a breaker on, it will just trip instantly. You'll see a wee flash inside. The same can happen with these short circuits, these tracking faults, where you turn it on, it trips instantly, but you turn it on again, and that was enough to just blow the fault clear. In this case, the fault evolved to the point it did not blow clear, and that's the point there was a bit of a bang. So let's open these. Let's take them apart and see what went wrong inside. Back at the bench now, we have the background to this incident, and these circuit breakers are labelled top and bottom, suggesting it was in one of the vertical industrial distribution boards with the busbars down the middle, and that's possibly where a lot of the flashover that triggered the fault of the other breakers happened as well, because you've got basically three phases, 415 volts effectively, between adjacent breakers. So I shall get a bit of, well actually, you know what? I shall take the tape off these and I'll drill the cases. And since it's going to take a moment to drill the rivets out of the middle breaker here, I shall pause while I do that. So 1 moment please. The rivets are out, let's explore. Now some of you may be wondering, why didn't they go and find the fault if it was a persistent fault like that? Well, the answer is because it was out of reach. It would have involved getting in some access equipment for that. Oh, this is still not opening very easily. And as such, because they had their work cut out already with general factory maintenance work, they didn't really have an opportunity to spend a lot of time trying to find that fault. Oh, this is not coming out. Is it actually kind of, is it stuck in with the explosion? Oh, he said, making enthusiastic noises. Yeah, this isn't so easy to open. If it's tricky to open, I shall pause. Another thing that's worth mentioning is that circuit breakers like this, you can't really blame the circuit breaker too much. I mean, I am a bit suspicious about the fact that when it blew up, it looks as though the only sign that it's flashed over into the inside is possibly through these little interfacing holes where you've got multiple circuit breakers triggering each other. I think that's what those are for. Right, is this going to come out? No, it's really not one to come out. I may have to pause again. But these circuit breakers, they're only designed to handle X number of actual fault conditions before they can break down in this way that they've actually done. There's a bit, there's an important bit. This is not coming apart easily, right? Tell you what, I'm just going to pause again. 1 moment, please. Okay, the front shell has come off, so this is looking more promising. Now, which of these, which half is going to have all the boom in it? I think it's that bit there. No, it's there. So this is absolutely, well and truly, totally blown up inside, hasn't it? There is the latching mechanism. That is no longer latching. Here's the heater, which is sooty, but it's not suffered damage. It's the bimetallic, although I can see splattered metal up there, which is unusual. Or is that just part of the weld? It's not. It's flashed right up through that. And the contact, where is the contact? So is this one contact plate here? And where is the other contact? Let me zoom down this. It's just very black. Has the contact literally exploded and disappeared? Have I missed something here? Here's the arc chute that is supposed to help quench that arc, but there are limits to what it can actually do. Here are the two little plates either side. Has the contact absolutely vaporized inside completely? Here's the solenoid mechanism that is designed to trip that in the event of an overcurrent situation like this. The little plunger should go down, and the little plunger can still go down. But ultimately, I don't actually see much left of the contact. I think the contact has been obliterated. We can find this out though. There's a melted spring in here. Yeah, let's open the other one. And we'll find if there was supposed to be another bit of metal. It looks like a bit of metal may have completely blasted, and it's possible it has gone through these into the other one. That will give us a clue. We'll be able to see the scorch mark in the other one. So I shall take the rivets out of this one with a little scorch mark on the side, and we'll see what it looks like on the side. 1 moment, please. Okay, most of the rivets are out. That rivet is not out, but that's fine. Let's see if we can open this in a nice controlled manner and see what's supposed to be in here. So, let me see. So this is going out to one side of the arc chute. Where's the actual contact? Where is the actual contact? I'd normally expect the contact to be swiping inside here. Oh, there it is. So there is the contact. If we zoom down this, by the look of it, yeah, there's the contact there. It's kind of like a knife contact, which is quite unusual. Can you see that in there? I'll try and push it up. So I'm guessing, is that contact? It looks like it. It's an unusual arrangement. And there is the guide that carries it up into the arc chute. I've not seen a contact like that before. It's quite strange. I'd normally expect to see sort of contact materials, but all I'm seeing is the copper to copper, which is reasonable enough for a contact material. Interesting. And the solenoid is acting, it's just punching down onto that. It does look like the flash has gone into this, and in doing so, it's kind of damaged the mechanism itself, the trip mechanism. But there we have it. So for those of you who are safety officers and have an opinion, I'll say yes. Things like this happen. It's just, you know, if you've got a situation where you turn a circuit breaker off, on, and every so often it goes pop and it trips, and turning it on again works the second time, there is a temptation to do that if it's not easy to find the fault. Normally, if a fault was at a lower level and it was accessible, then you could actually go and look for it by taking the covers off the junction boxes. But in this case, it would have required a lot more work, so they just relied on occasionally just resetting the breaker when it tripped. But in this instance, it exceeded its number of safe operating cycles effectively. I don't know if like they were going click, 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 trying to get it, which is not something I'd feel comfortable doing. Or if it was just randomly, just that one instant that it just decided that it wasn't going to be able to break that current. But the rating of these is, it's got 10,000 amps. It's designed to break fault current. Having said that, in a factory, you can end up with significant current faults. It's not like a sort of home environment electrical scenario. But there we have it. So what's left? Well, there is the contact. There is the contact on that. It is still in existence, but it's absolutely seized solid, which isn't really much of a surprise. Let's get that out. I'm just thinking here. And I know they're dangerous things. Oh no, there's the contact that goes onto. There's the contact that goes onto here, and there is a contact plate. I was talking crap. That's its resting position. That's its open position up there. So just to reiterate on that, this is it in its open position, and it's normally when it's made, it comes down onto this contact plate here. Where's that contact plate in the exploded one? Maybe that's why I couldn't find it. It was attached to the little solenoid. There's the contact plate. And it just looks like it's tried to break the circuit, but arc flash, you can see the weld here where the sparks run onto that, and that's where it's flashed over. But interesting things. So the moral of this story is that should you be in a situation you are resetting a circuit breaker into a suspect fault, it might be worth getting thick gloves on just for an extra layer of protection. It might not protect you completely, but it may just in that one instant protect you from the risk of getting burns in your fingers if flames come out the front of the panel. But there we have it, a well and truly exploded circuit breaker from one of those irksome intermittent faults that does occasionally occur.